Hello, welcome today's live webinar. Thank you for participating and joining us for this meeting. It is the first time we do this, so don't be too harsh to us, but give us your feedback, of course. Today we want to present you, cutting acrylics, basically. It's very simple. We have our application engineer here, Pascal Storm. He will, run the machine, show us the samples, explain to us the cutting results. We also have an external help from Christina from North America. So good morning, Christina. Can you hear us?
Yes, good afternoon, guys.
Yeah, hello. Yeah, thank you for joining us as well. It is not our native language, so of course we might need your assistance for this or that sentence or explanation. Thank you for supporting us today. So today, what do we want to show is plexiglass, 8mm GS plexiglass. We want to cut it. We want to show you the results. We want to show you the different, let's say, possibilities we have, and also give you the possibility, of course, to send us questions over the chat. So please use the chat function, write us questions. We will just include them in this presentation too. Yeah, we'll just make it flexible for you guys to basically be able to answer everything. I will warn you right away, we just have like 45 minutes basically for this presentation. It will not be enough to cover everything about cutting acrylics. So feel free to also contact us afterwards. You will see the contact details from me later after the presentation here or after the live webinar. Use that email address, send us your questions, and we can also do these demonstrations here in person. Come over to Lüneburg. Don't be fooled by the Eiffel Tower. It's in Lüneburg, not in Germany, not in Paris. And yeah, we will just cover everything when you contact us. So yeah, today we will use the M800. This is our shuttle table system here. Effective cutting area of 1,330 millimeters times 740 millimeters. Shuttle table, meaning that we have two different tables, one in the effective cutting area, so being processed. The second table here, accessible from three sides, basically enabling us to reduce the downtimes, loading and unloading the parts while the machine is cutting. Yeah. Pascal will now explain to us the general construction of the machine, because everything comes with the construction and with the, let's say, knowledge we have put in for 29 years now in the system. So yeah, the word is to Pascal to explain us the construction.
So basically what you can see here is the table concept beneath our raster plate that we have on top. This is the underside of the machine here. You can see there is holes on every section of here, which are separated by those parts here that will increase the vacuum that we have on each segment. The holes are in different size to support the flow of the air, to have a better vacuum on these different parts. So for example, this hole here is smaller, so you have a stronger vacuum on that side. And yeah, those are all segmented to support the, let's say, to support the gases that will suck away from the acrylic because it's lightly flammable. And then on top of the table concept, we have our raster plate, which you can see in that sample here. And there are small holes on there. And then on top of that, to cut acrylic, we have that so-called acrylic grid that will lay on top here. You can see it's separated into different kind of parts to just separate the flammable gas from the acrylic. So each chamber of here will be sucked away to minimize the risk of it getting burned.
So this, what we have shown here, the table, the under table, the raster plate, and the acrylic grid is here on this scale on an M800 installed. So we have prepared it. Pascal, just load the plate and show us how it works.
So you basically just load the plate onto the system. Then you tell the system that you are ready and you loaded the plate. Then you just press confirm on the shuttle table. The table will go in. So when it's in, you just set your point where you want to start your cutting, or you can start in a 0 point as well. Just select it. Then you have your set parameters for cutting the acrylic. Just place what you want to cut. I will cut our 2 samples right now. Select cutting, hit online, and then it just starts to cut the acrylic.
Hi, Pascal. While this is starting to cut, we have a question from the chat.
Yes, of course.
What would be the difference in the cutting edge quality if the exhaust was not sufficient?
Well, if you have no thick exhaust in that way, basically you will have slight burnings beneath the material because the gas will not be sucked away properly, and then you have a high risk of flaming. So the cutting quality is most likely the same, but you have high risk of fire beneath the material.
Thank you. And don't hesitate, everybody else, to ask your questions in the chat. I will ask them for you so we can be as interactive as possible.
Yeah, thank you, Christina. Maybe also just because this is a question that I would come up with right now is, well, we have the system here right now, but is this the maximum size that we can, or a maximum machine size? In total, we have 10 different machine sizes. The smallest one being the M800 here, the biggest one being the 3XL, so 10 machine sizes, basically from 830 millimeters times 1,330 millimeters effective cutting area over to 3.2 by 3.2 meters in size. So all the machine sizes we have cover this range of the effective cutting area. And so we are very open to, let's say, use a full sheet size blade. It's no problem. We have the right machine for this purpose. It's just that we are a little bit, let's say, limited to the space in our application center. So we still have the XL1600 here for processing half sheet sizes as well in the shuttle as a shuttle concept. We just use the M800 to be a little bit more flexible walking around the machine here. So Pascal, what do we see?
Yeah, right now we are finishing the cut of the acrylic, and after that's finished, I will show that to you in a detailed view on our sample table. Right now, as you could see, we were cutting small circles just to show how precise the tool diameters are. Because in the very small circles and in the squares and corners that I will show you right after the cutting, you can see that there's basically no losing of the material.
Pascal, when you say there's no losing of the material, that means we can put all the cut pieces close together?
Yes, that's right.
Is there a minimum to respect of how close we can be, and how close can we cut to the edge of the panel?
So with acrylic, basically, it's recommended to have a small gap between it. In some cases, if you cut really thick acrylic, then you might need a gap, let's say, close to the size or the height of the acrylic itself, just to minimize some deforming because of the heat we will put into the material. So as you can see, I can take off the plate right now and the samples just to take them with me. And then I can pull off the foil and then show it to you on the sample table. So as you can see here, taking off the foil, And then right here, you can see the finished part, crystal clear edges, and precise corners on there. Yeah, that's perfect. There you can see. And the small tool diameter here, that's really a cut. You can see on the side, it's really cut through, not just an engraving. That's just to show you how small or how thin the laser really is cutting the material. And as well on the other sample that I did cut, full of the foil there as well. Other side. That's a sample where I did cut the small holes. As you can see here, clear edges as well, and even really small radius is possible on that machine. As you can see, very precise cutting of the acrylic there.
Yeah, so the smallest hole that we made is 1 millimeter in size.
Thank you. We have another question in the chat. How fast can the machine cut the material?
So we are basically differentiating between two cutting variants. That what we did now was a quality cut, which is rather slow to just optimize the quality of the cutting edge. If you want acrylic to be crystal clear, you need to cut slow and with much heat in the end. And there's, of course, a possibility to cut acrylic in a rather fast way. That's why we call it fast cut, of course. But the quality of the edge decreases. You have slight marks on the cutting edge, but it's still clear, I would say, or still looks good if you compare it to other possibilities to cut acrylic.
Yeah, so the difference is basically, or the gap is huge. What we always show up is both extremes. So the maximization of the quality and the maximization of cutting speed, depending also on the laser power we use. In this configuration on the M800 right now, we use a 250 watt laser source. Yeah, so with that laser power, we are able to achieve much faster cutting results in the same material, but therefore, yeah, we will lose some quality, but it is not that it looks horrible. You know it very well when talking about, let's say, conventional, let's say processing methods like routing, milling, or sawing. You always have this completely burnt or let's say milky edge. This milky edge, this is what we do as a laser or as laser processing. We combine two different steps, because in the conventional way, you would saw acrylic or you would route it, and then you would need a flame polishing afterwards to achieve these, let's say, results that we now did with the laser. Due to the, let's say, burning process or to the heat impact that we have with the laser, automatically, we can achieve both at the same time. But this is not to be seen like this was the maximum cutting speed. We can go much faster than that, yeah? Right, great. Now you will ask yourself maybe, what's the difference? You have shown us you are cutting 8 millimeters GS. What's the difference? I also saw XT sometimes. Yeah, this is basically acrylics, independent of the supplier, basically provide two different acrylics. One being XT, so basically extruded, and the GS being cast acrylic. This is a complete different manufacturing process behind. Basically, yeah, we will have these two different acrylics on the market, and there are huge differences when processing, but also, of course, in the manufacturing. For the processing part, we have also shown or prepared two samples, basically, one being GS and the other being XT, to basically show the difference when cutting, but also when engraving. Pascal will show this in detail now. We can switch the spotlight. And Pascal, the word is yours.
Yes, of course. So as you can see here, we have two samples. We can start with the extruded one right here. As you can see, in comparison to the GS right now on the table, you can already see that the engraving has less contrast than the casted one. That is because the chemical chain of the extruded one is a bit smaller, so it melts or it gets, yeah, let's say, hard faster. That is, yeah, because of the chemical chain that we have in the production there. The cutting edge still looks the same, still looks clear. There's no difference in that. And after you cut extruded material, you have a slight burr on the edge that you can feel. In comparison to that, the GS material has no burr at all when you cut it. It feels really smooth on the edge. And as you can see, the contrast of the engraving is much better because it melts slower and stays hot longer than the extruded one. But the difference in the casted one is that you have a bit more tolerances in the thickness of the material when you buy it. But the cut still looks the same, crystal clear.
So now you'll think, all right, we didn't laser in it before, so now you want to start lasering acrylics. So you're interested in lasering acrylics, and the first thing to come up is like, well, it looks difficult to use. I'm a salesman. I shouldn't be able to use it, but I can basically. It's simple. And Pascal will show the general overview of the software, which enables this easy usage of the machine, and show also some features in the software now.
So as you can see, those are the files that we did cut on the acrylic on the table. Right here, you can just now, if you wanted to cut, select one, and then send it out. So the machine will start with the cutting process. And then on the side, as you can see here, you have the black layer for the contours. If you look behind that layer, you will have those parameters in there, which are consisting of material thickness. It's rather self-explaining. The focal length that you have in there, the laser frequency, which you can set from 400 to 20,000 hertz, because the laser beam is not a steady beam, it's rather just small pulses that you have in there. The laser power itself from 0 to 100%. The minimum power beneath that is the power we use for the edges and corners on there, because if you would always cut with the 100% laser power, you would have burnings in the deceleration and acceleration points. So this is the power that we use on the corners just to minimize the burning on there. Then you have the cutting speed, which is now at 11 millimeters per second. That is, of course, from 0 to 1000 millimeters per second. So 1 meter per second is the maximum speed that you can use on the system. And then for acrylic, what's rather important are the acceleration levels, because you want to have a slow melting process and a slow burning process. So you try to keep the system as smooth and slow as possible to just maximize the quality of the cutting edge in the end. So those are the two acceleration levels, and then you have a quality level that comes in with the accelerations as well. Right here, what's maybe important as well is the compressed air that we will use on the cut. So when you cut acrylic, you want as less airflow from the top as possible, because when you use compressed air on the top of acrylic, you will have a slight milky edge from the dust that you are producing when you cut, and you cool the acrylic rather fast when you blow it with air on top. And then just a motion control as well. For acrylic, you will normally use it on soft if you have slower speeds, to just maximize the smoothness of the driving path in the edges.
Pascal?
Pascal?
Another question for you.
Go for it.
Yeah, sorry. So is it possible to change the shape of what we cut, or to change the contour inside the software?
Yes, of course. You can change the contours in the software, or you can create your own contours on the software. That's both possible. So you can optimize jobs and change them, or you can create them right in there. Yes,
Thank
of
you.
course, I can show that real quick. So for example, now, if I have that contour right there, if I want to change, for example, now 1 knot to, let's say, 2 millimeters up, you can change that right here just to get a different kind of cutting path. Or what you can do is place, for example, a new contour that you can see here. It's either shapes that are predefined, or you can set your own DXF files in there that you can place there, or in the create software that we have as well. This is now the position one for sending out jobs. You can draw with freehand or your custom shapes that you want to have.
Thank you. And can you do this while the machine is processing, while it's cutting?
Yes, you can do that while the machine is processing, so you're not losing any time in preparation when you're already sending out jobs or you're already cutting jobs.
All right, thank you.
Of course.
So yeah, basically what we want to show is we have to do it as easy. I will meet you. I will do it. We can let's say use the machine in the full functionality, even being a very beginner and you just get the machine, all the information, all the knowledge that we have gathered here over the, let's say the parameters we have there for 15 years now. These are values, guide values that we have come up with here in our application center that we provide you with the machine when you get the machine. So you start not from 0, but you start with 250 sets of parameters and parameter sets to start with from and have the perfect values and settings for cutting these different kind of materials. Next to the laser, you hopefully know, or maybe you're not, we are based on a Zint movement system. So this enables us further in the sense that we are not only lasering. So maybe you can move to the laser head itself or to the bar. So what you see here is the laser head here in the first position with the top vacuum. Yeah, you can bring it forward. Even though I'm 2 meters tall, like it's easier like this. So this is the laser head, having the lens here inside where we laser, and we have the extraction here with the top exhaust with this hose here. Then in the middle position here, the small one is the ICC camera from Zint. So basically, we are able to read registration marks when having printed materials. So this allows us to position the file and the contour according to the print we see on the table. On the second tool position, in this case, we have a 1 kilowatt router. This 1 kilowatt router can be used for example, beveling edges, enabling you to drill holes not completely through. So extending the possibilities you have with the laser to have a router as well as like 45-degree angle and so on. This is also within hose here, but a separate one. We don't want any dirt or dust on the machine when lasering. So we extract it separately from the system here. This is now one example of our options or tools we can offer. We have a wagon here basically showing a few examples that we have. So if it's marking or basically, marking or printing, we are able to use, let's say, a printing module. So you insert a cartridge here, you place it in the tool position 2. So you are able to print a QR code or mark, or let's say, basically for traceability, most of the times, able to print directly on the material, or for example, combine it with the label module here. So place a label, a blank label, print a QR code, a running number, whatever you desire, and enable you to not having certain steps after cutting, but combine everything on one machine. So now what we want to show is routing and lasering. So we want to bevel an edge and then laser the part out afterwards. In combination to that, we have this prepared with printed acrylics. So maybe we can move the spotlight first for here, so you can see this is the sheet that we have prepared, also from plexiglass. In this case, printed from Swiss Key Print, having the fiducial marks or registration marks. So we will now read the dots, position the print to the file that we have, then bevel the edge with the router and laser through. Yeah, Pascal, the stage is yours.
Yes, of course. So I will start by sending out the job. I choose the second contour now. When I press online, I will have the window for the camera settings. I'll press enter now. It writes to the camera mark. Read every fiducial mark that is required to cut the contour in that position that we wanted. After I did that, I will press confirm, and we will start with the routing process first to create a bevel edge on the contour. As you can see now, it rounds or drives around the contour that we want to cut out. And after the routing process, we start with the cutting. So basically, as you can see, the switch between the two tools is smooth and automatic. You don't have to select your tool manually. You can just assign it in the program to say this line should be routed and this line should be cutted, and then the system does it automatically for you.
We have another question from the chat room while this is happening. How thick can we cut the acrylic with getting a perfect edge quality?
Okay. I have some samples on the table as well to show up to which thickness we can cut. I will explain that while I show the sample that we just did cut as well. So we shuttle the table now to the front.
You see, Christina, even I can handle the machine. I just shuttled out.
You're full of good skills.
Yeah, a flexible salesman, I would say.
So then we take out the foil of that as well. So, and we get the camera focus in. Yes, perfect. So here you can see what we just did cut. As you can see, there's a small bevel edge around the cutting area, and then crystal clear edge again on 8mm GS acrylic, just like the cut before. And then, of course, that's what the product looks in finish line with the small standing foot beneath it. So, and back to the question we just had. We guarantee to cut up to 25mm of acrylic in good quality. As you can see here, we have a foot from our 25-year anniversary, which was in 2019. Smooth edges. But of course, we did some testing and we tried different things around. So that is as well a 35mm block of acrylic that we did cut. And you can still get those results on here. But it's, of course, a high flammable risk on that kind of material. So on that kind of thickness. But as you can see, we will still get those good looking clear edges.
So Christina, I saw there's a question. It's too far away, even though I have glasses. So can you read
Yeah,
it?
well, the last question was about the new camera system. I believe the question probably is about the scanning system. Maybe we can get to it a little bit later or at the end of the presentation.
Yeah. Yeah, so basically, I can immediately answer to that. What
Okay.
we have, or what we have used here, and what we have shown, is basically the ICC camera. So we have a certain field, so a small camera placed to the table. So we have an area where we can find fiducials and read a separate or a fiducial separately to basically align the print to the file. The new camera system is completely state of the art in this sense. So we install the camera, or a camera bar basically, behind our actual bar. So we have our frame here with the optic heads, or the laser head, the router, and so on. On the back of the machine of this bar, we install this camera frame, and it is over the complete length of the machine. What allows us is we are not, let's say, bound to find individual fiducials, but we scan the complete table. This is basically working for every application. So we have, of course, now focused on the textile market because there's a shrinking and so on, but also for acrylics. If you have printed material, any kind of sense, we are able to scan the complete table. So imagine you have a full sheet size plate, 3 by 2 meter. So you have like 40 printed contours on that plate, and now you would read and have to read each fiducial individually to, let's say, align the print to the file. And this way, with the new camera option, we scan the complete area in 4 seconds. Basically, we are even able to generate a file. So the possibilities are endless with this camera now, and it's just been released a few months ago. So we are now very active in promoting it. So if you have, or if you're interested in seeing the camera live and get a presentation, contact us, send us material over. We have the camera here installed. We are able to show you the cutting and the scanning process at the same time here.
Thank you. I will
Next,
put the link. Sorry to interrupt, guys. I will put
good.
the link for the video we have for explaining what the scanning software is. The link will be in the chat.
Yeah, perfect. Thank you very much. So now we have cut transparent acrylic, basically all the time. It's printed or not, but it was transparent GS acrylic. So now the question is, are we also able to cut colored acrylic? Pascal, are we?
Yes, of course. Even though some colored acrylic might be a little bit harder to cut, we can still do that. As for example, now, right here, I have a black sample of acrylic. That's 3 millimeters now. But as you can see on here, if I turn it against the light, there's no marks on the back side or the front side of the material. Quality is still looking the same. You, of course, cannot see through it because it's colored as well, but the cutting edge still is pretty clear. There's nothing that you can see, or no marks at all that you can see on the black material. What is a bit harder to cut is white acrylic, because in that case, especially in the edges of the acrylic, you can pretty much always see some black burning marks if you do not use the right parameters for that. But with the eurolaser, you can set your parameters up that way that you have no visible marks at all on the front, back side, or on the edges, on the cutting edges as well. So on the corners right here, you can see everything still pretty white and clear, even in the corners there. And then, of course, we have a sample here. So basically, nearly every color that you can think of, we did try to cut, and everything looks fine, even if it's transparent or matte, or yeah, it still looks good.
Another question, guys. Sorry.
Yeah.
What was, from all the samples you cut so far on the M800, what was the wattage used?
So the wattage we use, or the laser source we use, was a 250 watt laser source in this case. We have the possibility, because machines from us, or the eurolaser assembles each machine individually for the customer. Basically, over the system size, the laser power, the table concept, everything has been discussed before you get a detailed quotation. This enables us to configure the machine to your demands and to your application, because if you're cutting 2mm acrylic, you don't need a 650 watt laser source. So what we do is we discuss that in detail in advance, and then we have the possibilities of using a 60 watt laser. This is the smallest laser power we use, up to 650 watt. There are only two companies that we provide or that provide us the lasers, and this is Luxina or Syndred. We are very, let's say, proud of just using these two, because they're just the best on the market that you can get for sealed off CO2 laser tubes. And we only use those two here in that sense. Yeah, then we have the recycled acrylic. Pascal, is recycled acrylic, does it work like normal acrylic? Do we have any disadvantages, or because it's a topic that gets more and more important for everyone? Is that something that we can also process with the laser?
Yes, of course. The recycled acrylic that we did cut or did test, we have much certificates from different kind of providers from acrylic. They were all perfect. There's rather no difference at all in cutting them. So basically, it just works as fine. The edges are still as clear as normal acrylic, or new acrylic, as I should say. That's no difference at all. It still works as a charm, like a charm.
To be precise, the white and the black sample that we have shown before as colored acrylic is basically recycled acrylic. So this is samples from Plexiglas Proterra, so their recycled line that they provide. And basically this contains 90% recycled acrylic and 10% non-recycled acrylic. They do this for a good reason. They want the surface and the bottom to be non-recycled, just to have these, let's say, surface quality of a non-recycled acrylic, but the inside has been recycled and used. So there are 3 layers that they use for their acrylic. So what are the tolerances in cutting acrylic? Yeah, the tolerances in cutting acrylic, there are no tolerances. We have a tool diameter. That tool diameter is depending basically on the lens that we use and the optical head. For thin material, we use a small lens. For thicker materials, we can use a bigger lens. But in average, we are talking about a tool diameter of 0.2 to 0.3 millimeters in tool diameter. So in comparison, if you are familiar with the milling and you have a routing spindle and you have a 4 millimeter for the straights, then you have to change the 2 millimeters for some corners, then a very small spindle to make or try to get corner or edges as edges and not like round. So this is with the laser, just all in one. We have the possibility to use this very small and detailed tool diameter here. We have also for you, or we have prepared some certificates, because in the end, we have all the suppliers that come to us. Hey, eurolaser, you have great machines. Can you do us some tests with our new material? So for the recycled series models of different suppliers, it is a 3A, Plexiglas, so room. All the manufacturers of acrylic, they contact us. They ask us to do tests. So on our website also, you can find these certificates and our, let's say, honest opinion about these different acrylics. And yeah, just get an idea of what we have done. You can request also from us what thickness it was, which color it was, to identify, all right, if I do buy this material, it will enable me that it works perfectly afterwards. Yeah. The time is running out. We don't have so much time, as I said. Normally, as I do have as a salesman, you come here, we drink a coffee. I have 8 hours to show you around and 8 hours to explain to you the machine and the ins and outs that we do and the options that we have. time is limited, so please use the formula and or the contact details that will be shown afterwards, and send us an email if you have some materials or some trouble in cutting acrylic right now with an existing machine, for example. Send us the material over, or your material. We can do a web demo. So basically the setup here will be the same. You will have cameras here that we can show you the cutting, but a visit in person is always the best solution. We are close to Hamburg, so the international airport from Hamburg is not far away. So yeah, feel free to join us. And also very important is next year on the 11th and on the 12th of this September, we will have our 30 years anniversary. That anniversary is a big event for us. It is also, as such a long-term, let's say, player in manufacturing these laser machines and high-end laser machines. We want to show you what we have gathered over the 30 years of experience with our customers and partners. So there will be a ton of applications, a lot of experts also from the suppliers being present that you can ask the questions. You can ask us for the manufacturing as well, or for the processing. So save the date, join us for the in-house exhibition. It's going to be a great show. And it's not only simple, straight facts. The evening program is as professional as the whole show and the whole event before. So, Christina, thank you very much also for helping us out and giving us the questions, for today's webinar. Pascal, thank you also very much for describing and showing us the samples and cutting these samples. Christina.
My pleasure. Hey, we have 2 more questions actually, if we have time to answer them.
Yes, of course.
One question was about the pulse length that we used for cutting the samples.
The laser unit that we just used has a pulse of or a pulse length of 10,600 nanometers.
Thank you. I was about to answer the same answer. The other question is... Yeah, go ahead. Sorry.
Yeah, of course, we did some tests with other pulse lengths or wave length, but for the acrylic, the 10,600 nanometers suited the best.
Okay, thank you. The other question was about cutting different types of material. For example, a COC film of 0.1 millimeter. Like a PT carrier film, can we cut that with our system?
Oh, I would then refer basically to use the email address that will be shown afterwards, just because the time is a bit limited as well from our side now. But there will be the email address from me and the contact details. So please send the email to me, and I will make sure that you get the answer right away to the different kind of materials and applications now that's been answered, or questions, and yeah, we'll take care of it. Yeah.
Thank you very much.
Yeah, thank you as well for joining us in the name of eurolaser. Also, this was the first time. Thank you for joining, and hopefully we will do this more often. And of course, we also get some practice now. It's the first time, but I think it was quite a very pleasant one. Sometimes I miss the answers as a problem. So yeah, but you get used to it, I think. But Christina, thank you. So I had a little bit of conversation with you that helped me a lot. Thanks.
You're welcome. We'll do this more often.
Thank you. Bye-bye.
Bye-bye.